This is Ms. Wiles, and in this video we're looking at equivalent expressions. Of course, here we have a quadratic equation, the 24x squared plus 29x minus 4. And before we jump in, we need to look at, when we're looking for equivalent expressions, is look at our answer choices and see what we have to choose from. And we notice that every one of our answer choices is binomial multiplication. And so we can think about FOIL. Now, depending on how you work out this problem determines your next step. Do you want to work from the quadratic function and factor by grouping and see which one of these you get? Or do you want to use these that you already have to see which one matches what you're looking for? It's my personal opinion, after lots of experience, that it's easier in this kind of problem to work from your answers to what you have in the original question. And so the thing that I like to focus on first are what's different about some of these and what should I be looking for. Knowing how FOIL works, I know that the L is the last two numbers being multiplied together. So you're going to see me do some drawing here and erasing so I can show you where I'm thinking and what I'm doing. For letter A, I would have negative 1 times 4. Negative 1 times 4 for the last term. And maybe I'll be able to figure out how to leave this here. Negative 1 times 4, and that does equal negative 4, and it matches what I'm looking for in my original. So A is still in the mix. It's still possible. With letter B, I have negative 1 times negative 4. That equals positive 4. It is out. B is not the correct answer, and I've at least narrowed down the possibilities here. With C, I've got negative 4 times 1. Negative 4 times 1 is negative 4, so it's still in the mix. And with D, I have negative 4 times 1, and so it's still a possible correct answer. Then I look at the first term. The first term is 24x squared. Now for this, I'm going to look for the first term. The first term is the first term of each binomial multiplied by itself, by the next term. So I'm going to do this in red. Looking for 24x squared, I have 8x times 3x. Well, 8x times 3x is 24x squared. 12x times 2x is 24x squared. Oh, but it's out of there. I shouldn't even be looking at that one. Shouldn't even waste my time on it anymore because it's already out of there. 8x times 3x again. I've already checked that in letter A. It's okay. And 12x times 2x is 24x squared. So I haven't been able to narrow anything down. Once you've checked the first and the last term, and I would say to you that you can check the first and the last term without writing anything down on your paper because you're not having to combine anything. You're just multiplying, so we don't really need to have all this on our paper. When you look at B and you do the negative 1 times the negative 4 and you're thinking that doesn't match the negative 4, then yes, mark it out. What you have to do on the other ones, because the first and the last terms didn't eliminate any of them, is look at the binomial multiplication and see what you get. So you can check in any order, whatever looks good to you, you're going to check to see what you get. And with letter A, if I'm doing 8x times 3x plus 4, and negative 1 times 3x plus 4, remember this? You got to use it. 8x times 3x is 24x squared. 8x times 4 is 32x. Negative 1 times 3x is negative 3x. We're going to put it under the 32x because they are like terms. And negative 1 times 4 is negative 4. When you combine your like terms here, you have 24x squared. You have 32 minus 3, which is what? 29. 32 minus 3 is 29x, and then minus 4. Because this matches our original question which of these equations is, or which expression is equivalent to that, then we found our answer. Our answer is letter A. If you can go through binomial multiplication very quickly, it's probably more logical and more organized if you just do it for each one that you can't eliminate that first and last term. If you can eliminate something quickly, eliminate it. If not, for each and every answer choice, do your binomial multiplication and compare it to the original problem. And that's all I have to say about that.